Autophagy, while often discussed in the context of intracellular recycling and energy regulation, also plays a surprisingly influential role in maintaining the integrity of the gut and the delicate balance of the gut microbiota, both of which are now recognized as critical players in the development and persistence of obesity. The gut is not merely a digestive organ, it is a complex ecosystem, housing trillions of microorganisms that influence immune function, metabolic signaling, and even behavior. When this balance is disrupted, as often occurs in obesity, the result is increased inflammation, impaired nutrient signaling, and a greater tendency toward fat accumulation. Autophagy emerges here as a central mediator, acting both at the cellular level and systemically to preserve the gut's structural and functional integrity. One of the key ways autophagy contributes to gut health is by maintaining the intestinal barrier. This barrier is composed of tightly linked epithelial cells that prevent pathogens, toxins, and undigested food particles from leaking into the bloodstream. In obesity, this barrier becomes compromised, a condition known as leaky gut. When this happens, bacterial fragments like lipopolysaccharides, LPS, escape into the circulation, triggering a persistent low-grade inflammatory response throughout the body. This systemic inflammation not only contributes to insulin resistance and metabolic dysfunction but also further damages the gut barrier in a harmful feedback loop. Autophagy directly supports the gut lining by clearing damaged epithelial cells and promoting the survival of healthy ones. When autophagy is active, tight junction proteins that hold the gut barrier together are preserved and regenerated. In contrast, when autophagy is impaired, something often seen in obesity and high-fat diets, the epithelial lining weakens, inflammation increases, and microbial populations shift unfavorably. In this way, autophagy deficiency contributes both to a breakdown in the gut wall and to the metabolic disturbances that follow. The influence of autophagy extends beyond the physical barrier and into the realm of gut microbial balance. The composition of the gut microbiota, specifically the ratio of beneficial to harmful bacteria, has been strongly linked to obesity outcomes. For example, a microbiota rich in firmicutes and depleted in bacteroidetes is associated with greater calorie extraction from food and higher fat storage. Autophagy interacts with gut microbes by shaping immune responses, modulating antimicrobial peptide secretion, and affecting the turnover of mucosal cells that host these microbes. When autophagy is functioning properly, it supports a microbial environment that favors leanness and metabolic balance. When it fails, opportunistic bacteria can thrive, fueling inflammation and weight gain. Encouragingly, there is growing evidence that enhancing autophagy, whether through fasting, exercise, or certain natural compounds, can help restore gut barrier function and microbial harmony. In animal models, interventions that increase autophagic activity have been shown to reduce gut permeability, lower inflammatory markers, and even reverse unfavorable shifts in microbiota composition. This suggests that autophagy not only responds to changes in the gut, but can also drive beneficial changes when strategically activated. The relationship between autophagy and the microbiome is also reciprocal. Certain gut microbes produce metabolites like short-chain fatty acids, especially butyrate, that stimulate autophagy in gut and immune cells. This bidirectional interaction creates a positive feedback loop. A healthy microbiome promotes autophagy, and autophagy sustains a healthy microbiome. In contrast, when obesity disrupts microbial diversity and lowers beneficial metabolites, autophagy is further weakened, exacerbating gut dysfunction and systemic inflammation. From a therapeutic standpoint, this connection opens up multiple promising avenues. Supporting autophagy through dietary patterns such as time-restricted eating or plant-based high-fiber diets, probiotics that enhance autophagic signaling, or prebiotics that nourish beneficial microbes could help rebalance the gut ecosystem and reduce obesity risk. Pharmacological approaches may eventually target this axis directly, restoring gut integrity and immune tolerance in those with advanced metabolic disease. In summary, autophagy serves as a linchpin between the gut and the rest of the body, preserving barrier function, shaping microbial populations, and moderating immune responses. In obesity, when this system falters, the consequences are felt across every organ system. But the capacity of autophagy to adapt and recover offers real hope. By supporting this deeply conserved cellular process, we may not only protect the gut, but also alter the course of obesity itself, at the microscopic, systemic, and behavioral levels.